Dr. Saran, he's presently the assistant professor at Coimbatore Institute of Technology, and he has obtained his PhD in Information and Communication Engineering from PSG College of Technology, Coimbatore. His educational background includes a master's degree in computer science and engineering from Kumaraguru College of Technology, Coimbatore, an MBA degree in human resources from Bharatiya University, Coimbatore. He has completed his bachelor's degree in information technology at Coimbatore Institute of Technology. With 8 years of experience, he has developed expertise in both teaching and research. He has an extensive academic record with over 10 papers indexed in Scopus, 4 papers in SCI Index journals, and 5 papers in various international journals. Additionally, he has presented more than 25 research papers at various national and international conferences. His research contributions also include 6 filed patents with 3 patents already published. He has completed 15 courses in NPTEL and 5 courses in Coursera. Furthermore, he has actively participated in various faculty development programs, seminars, conferences, at various prestigious institutions, and he has successfully completed 2 funding projects under the Tamil Nadu Council of Science and Technology Student Project Scheme. So now the platform is yours, Dr. Saran.
Thank you, ma'am. Thank you for the wonderful introduction. Thank you so much. Is my voice is audible, ma'am?
Pardon, sir?
Is my voice is audible, ma'am?
Yes, you are completely audible and you may start your session.
Okay, ma'am. Okay, thank you. Thank you so much. Is my screen is visible? Is my screen is visible, ma'am?
Yes, your screen is visible.
Okay, ma'am. Okay. So, good evening, participants.
Sir, you
So,
put it in the slide mode.
hello, ma'am.
Sir, you put it in the slide mode. Slide mode.
Yeah, slide mode only, ma'am.
It is there.
Yeah, slide mode.
Okay.
Slide mode only, ma'am. Is it viewable?
Actually, the sidebars are also showing. So I think if you can click the slideshow once again, it will be better.
Okay, ma'am. Wait a minute, ma'am.
Yeah. Good. I think it's coming.
Is my screen is visible?
Yes, it's visible.
Okay. So, good evening, participants. So in the previous session, you had an so in this session, idea about what is data pre-processing and what is feature engineering in machine learning and what is data pre-processing and feature engineering concerned with electrical engineering applications. So this is my agenda. So first, I will be covering introduction to data pre-processing. Under data pre-processing, we have what is data quality and what are the various tasks in data pre-processing. Next, we have an introduction about data cleaning, data integration, data reduction, data transformation, and data discretization. So before moving to the slide, first we'll have an introduction about what is data pre-processing. So data pre-processing is basically concerned with will be processing data to remove any errors or noise or incomplete data, all those things. So why this data pre-processing is important is in order to gain more performance with the machine learning model, we have to ensure good quality of data. So in this way, this data pre-processing is very important. So before moving to data pre-processing, we'll have get to know what is data quality. So data quality and why we need to pre-process the data. So once we have an accurate data or a complete data, we'll get a more performance. So that is the main need for data pre-processing. And also we'll be measuring the data by means of these terminologies, that is accuracy, completeness, consistency, timeliness, believability, interpretability. So accuracy in the sense whether our data is accurate or not. For example, If you say your date of birth is January 2, the data will be not an accurate because you have to say your date of birth along with your error, that is 1st January 1990. So that is about accuracy. Then completeness is in the same way. We have to make the data complete. For example, if we have an incomplete data like your age is not given in integer value, if suppose minus, that is about completeness. Consistency is some modified but some not, that is dangling, that is your data has to be consistent so that it can be processed easily. Timeliness in the sense whether your data has to be updated timely. For example, weather data, temperature data, all those data you have to update regularly so that you can check the quality of data for pre-processing. When concerned with electrical engineering department, timeliness in the sense of what is the voltage at the particular point of time, what is the resistance available, that is about timeliness. Next, coming to believability, whether the data we are having is believable or trustable, whether it is correct data or it is a tampered data, all those things we have to check it out. That is about believability. Next one is interpretability. That is how easily the data can be understood. Whether you have a data that can be understandable easily. So that is about interpretability. So these are the various measures to ensure the quality of data before we are moving to data pre-processing. Next. So this is the main need or a necessity for performing data pre-processing in order to make your data accurate, complete, consistent, timeliness, believable, and interpretable. Next, we move to what are the various tasks or what are the various steps in data pre-processing. So some of the steps are data cleaning, data integration, data reduction, data transformation, and discretization. So these are all the various tasks you will be performing under data pre-processing. So first one is data cleaning. So data cleaning is something about you will be removing the missing values, or you will be replacing the incomplete values, or you will be replacing the errors or outlier values. Errors or outlier values in the sense, if the column particular column represents a voltage value, if it is supposed to be minus 98, so that will be called as an error value or an outlier value. Okay, so that is about data cleaning. You will be replacing the missing values, incomplete values, or error values. Next one is data integration. So data integration is something about you will be merging or combining multiple data in order to get one final data. For example, if you have a length and a breadth, or if you have a inductance and a resistance, you can calculate a voltage. So that is about data integration. So one column will be representing a current value, one column will be representing a resistance value. With the available two columns, you can easily calculate a voltage value, that is V is equal to IR. That is about data integration. That is, you will be merging multiple data to create one data or an aggregation of data. Next one is data reduction. So data reduction is something about you will be reducing the size of a data or a dimension of the data. If your data is supposed to be 10 cross 10, that is, it has 10 rows and 10 columns, you have to make data reduction in the sense you can reduce into 5 cross 5 or 4 cross 4. That is about data reduction. uh, Under data reduction, you have many methods, that is dimensionality reduction, numerosity reduction, data compression. Next one is data transformation and data discretization. That is, you will be transforming or converting a value to another form. That is about data transformation. So data discretization is you will be splitting the values. That is about data discretization. Okay, so these are all the major tasks concerned with data pre-processing. So now we'll move to the various methods under each of these tasks. First, we'll move to what is data cleaning. So I have already said data cleaning is something about you will be removing the missing values or incomplete values, or you will be removing the error values. So data in the real world is data. That is a lot of incorrect data. For example, when concerned with electrical engineering department, instrument fault or human or computer error, transmission error, all those things are data faults or errors. So you have to make clean all those error values in order to get good performance of a particular machine learning model. So you have to remove the clean the incomplete data, noisy data, inconsistent data, intentional data. So incomplete in the sense occupation is equal to, if it is supposed to be blank, that is about incomplete data, that is lacking of attribute values, lacking of certain attributes of interest, or containing only aggregate data. That is about incomplete. Noisy in the sense containing noise, errors, or outliers. If suppose if our salary is in the value of minus, that is negative value, that is about noisy data. Next one is inconsistent data containing discrepancies in codes or names. For example, age is equal to 42, birthday is equal to. So birthday is something about which day we has one, but here it has given us something. So if your rating is 1, 2, or 3, now rating is A, B, C. All those will be called as inconsistent data. Next, intentional is distinguished missing data. If suppose you are given your birthday date as January 1, it is about intentional. That is, you have to mention your year of birth also. So this is about uh, data cleaning. First, we'll have what is the incomplete value. That is, data is not always available. The missing data may be due to equipment malfunction, or we will be making some errors during recording, and data not entered due to misunderstanding, or data may be considered important at the time of entry, or not register or changes of data. So all these missing data or error values has to be corrected. So how to handle the missing values? So we can, for some cases, we can ignore that particular value or a particular tuple, or you can fill in the missing values either manually or following some methods. If you need to fill in the values automatically, you can follow a global constant value or attribute mean of the sample belonging to the same class member, or a most probable value. For example, if you need to fill the age of a person which is missing, you can fill the average age. Or if you need to fill some global constant value which is missing, you can put that value. So this is about some ways of handling the missing data. Either you can handle it manually or automatically by means of replacing the global constant or attribute mean or a same class. So this is about a first category of data, that is noisy, incomplete data. It is completed. Next one is noisy data. So noisy data in the sense it will be an error or a variance in the measure value. Incorrect attribute values may be due to faulty data collection instruments, data entry problems, transmission, technology limitation, inconsistency. So here other problems which is require data cleaning is duplicate records, incomplete data, or inconsistent data. So noisy is somewhat is error or an incomplete value will be called as a noisy data. So next we'll move to what are the methods to handle the noisy data. So we have four different types of methods. First one is binning, regression, clustering, combining human and computer inspection. So binning is nothing but you have different methods, that is smooth by bin mean, smooth by bin median, smooth by bin boundaries. That is, you will be categorizing the given data into multiple bins. That is, you will be grouping the data into two or three groups, and you will be taking the mean of a value and putting and replacing the missing values. In the second case, you will be taking the median of the value and you will be replacing. In the third case, you will be taking the boundaries of the values and you will be replacing. Okay, so that is about binning. So you will be sort the data and partition into equal frequency bins. So given data, you will be categorized into three different clusters or three different groups, and you can replace the missed data by means of means or median value or boundaries. Second category is regression. So you will be smoothing by fitting the data into regression functions. So you can use any linear regression function and apply the value, and you can predict the value so that you can replace that predicted value for the missing value. Next one is clustering. That is detect and remove the outliers. So you can cluster the group of data which is similar, and you can remove the missing data. Next one is combined computer and human inspection. That is, you can detect the suspicious values and check by human. That is, deal with possible outliers. Next one is what is data cleaning as a process. So data cleaning is nothing but a data discrepancy detection or data migration and integration. So discrepancy detection in the sense you will be using metadata, that is some data about previous historical data, or you will be field overloading, or you will be checking the uniqueness rule, consecutive rule, and null rule. That is, you will be using some common rules like bin means, bin median, all those things, and you will be replacing the data. So some of the common tools available is data scrubbing and data auditing. So data scrubbing is nothing but you will be checking for errors or outliers, and you will be making corrections manually. You will be using some domain knowledge. For example, you can know the dates of some common festivals, and you can replace it with missing values. Data auditing is you will be analyzing the data to discover the rules and relationship to detect the violators. That is, you will be make an analysis of the given data, and you will be finding the relationship between the multiple columns or multiple tuples, so that once you find the relationship, you can put a value for the missing values. So this is about.
Hello, am I audible? Sorry to interrupt you, sir.
Yes, ma'am.
So your slides are not changing. I
From
think
here I am changing, ma'am.
it's not showing. So you can again, sir, in the top bar, there's a slideshow tab. You can click that. Then it will change to us also. It will visible. Yeah. Now we have.
Now, ma'am.
Yeah, but it's in the PowerPoint mode. Can you please switch on to the slideshow mode? I mean F5,
Yeah, slideshow only, ma'am.
but it's not showing in that way. It's showing the PowerPoint mode.
Wait a minute, ma'am. Whether it is viewable, ma'am?
No, not yet, sir. It's not yet. But in that case, if, the slides you'll have to change manually. Now the slides are
Because
changing. Yeah,
screen.
it's not full screen mode.
Now, ma'am.
No, not
Now
yet.
it is. Now, ma'am.
It's not the full screen mode, sir. So, slideshow. Can you just click to the slideshow in the upper tab? It's showing. Can you
Yeah,
put
I have done slideshow only, ma'am.
animations? Then you go to the slideshow, sir, and from
Yeah, yes.
from current slides, or how far have you gone from current slides, sir? In the
Yeah,
upper
yes, ma'am.
tab only, not there. The cursor you put it from current slide. So go up, sir. You go up. So you
Is it viewable?
cursor in the from current slide, sir.
Yes, ma'am. Current slide only, ma'am.
So you can
Now,
share the
ma'am.
whole screen. You can stop the share, and once again you have to share the whole screen so that the other slideshow will also be visible. You have selected a particular screen to be shown. That's why it is not coming. Share whole screen.
Now, ma'am.
Yes, now it is coming. Now it is coming. Perfect.
Okay.
Thank you.
Yes, sir. Now it's okay. Thank you, sir.
Okay. So next one is data migration and integration. So we will be migrating the data using some migration tools so that some transformation can be done. Next, you have one day tool, that is ETL tool, that is extraction, transformation, loading. That is, you will be extracting the data and you will be converting the data into various form by means of transformation techniques. Next, you will be loading the data for processing. So this ETL tool will allow the user to specify the transformation through a graphical user interface. So you have one tool. With available of the tool, you can extract the some required data from the given data, and you can transform the data into various forms, and you can load the data to the users. Next, integration is of two process: iterative and interactive. So iterative in the sense, repeatedly you will be integrating the given data to come to create one data that is required for processing. So interactive in the sense, you will be interacting with the user by means of an user interface, and you will be merging the two data that is required for data pre-processing. So this is about data cleaning. So under data cleaning, you have various types, that is incomplete, noisy, inconsistent, and intentional data. Next, we move to the next task in data pre-processing, that is data integration. So data integration is nothing about, will be combining the data from multiple sources in order to create a common data. So integrate metadata from different sources. So that is, you will be integrating multiple data or multiple column to create a common data that will be required for processing. So here I will be facing one problem. There is entity identification problem. So identify real world entities from multiple data sources, that is Bill Clinton equal to William Clinton. So if the name is same, that creates some problem. That is a main problem with data integration. That problem will be called it as an entity identification problem. Next, so detecting and resolving data value conflicts. For some real world entity, attribute values from different sources are different. For example, some person will give your date of birth as 12 Jan 1993. Some persons will mention as 12/01/1993. So when you perform integration with these data, the value of the entity will remain different. Next possible reason is different representation, different skills. As I said, some people will represent Jan, or some people will represent 01. In concern with electrical engineering department, some will use a common metric, some will use a British units. So these are all the problems we'll be facing when concerned with data integration. So next we'll move to how to handle redundancy in data integration. That is, when you have a redundant repeated data, how to handle redundancy during data integration process. So redundant data occur often when integration of multiple databases. That is object identification and derivable data. That is same object will be used in two different databases. At the time we'll be facing redundancy problem. And also derivable data, one attribute may be derived attribute in another table. For example, annual revenue. For when you given a salary of a person, monthly salary of a person, you can derive the annual salary of a person. So that is about some redundancy problem. Next, redundant attributes may be able to be detected by correlation analysis or covariance analysis. So whenever a data is given, at the time you can identify the redundant data by means of these two measures, that is correlation analysis and covariance analysis. So you have to integrate the data carefully from multiple sources so that to avoid or reduce the redundancies and inconsistency, and you can improve the mining speed and quality. So this is about handling data redundancy in data integration. So next we'll move to the methods to handle the redundancy during the data integration process. We have two methods, that is correlation analysis and covariance analysis. So correlation analysis is about for nominal data. So you will be using only this for nominal data. Under correlation analysis, you will be performing chi-square test, that is uh, observed minus expected value divided by observed expected value. So when the larger the value of psi square, the more the variables are related. So we'll be making a relation between the two different variables by means of this psi square test. So the cells that contribute the most to x square value are those that actually count is very different from the expected count. So a particular cell that represents a high value of chi square will be same to the two databases. So correlation does not imply causality of number of hospitals and number of car theft in a city are correlated. So whenever you are performing correlation analysis, two different databases has to be somewhat related. For example, patient database, doctor database. Between these two databases, you can perform a correlation analysis, whereas number of hospitals and the number of car theft in the city are not correlated. Okay. So both are casually linked by a third variable that is called as population variable. And also you can perform correlation analysis for a numerical data by means of Pearson coefficient. So this is a formula for calculating correlation by means of Pearson. That is R of A comma B, where n here n represents a number of tuples. A and B are respect to mean of A and B. So if a correlation Pearson coefficient is greater than 0, A and B are positively correlated. If it is 0, both the variables are independent. If it is negative, the variables are not correlated. So what is about correlation? It is nothing but it measures the relationship between the two objects or two variables. So we can calculate the mean by means of the A dash k is equal to a k minus mean of a divided by standard deviation of a. So b dash k is equal to bk minus mean of b divided by standard deviation of b. So correlation of a comma b is equal to a dash into b dash. So this is about correlation. Next, we'll move to covariance. So covariance will be applicable to numeric data. So here covariance of A comma B is equal to expectation of A minus A bar. A bar denotes the mean of A. B minus B bar. B bar denotes the mean of B. So correlation coefficient R of A comma B is equal to covariance of A comma B divided by sigma A into sigma B. Sigma denotes the standard deviation. So if it is a positive correlation, both the A and B tend to be larger than the expected values. If it is of negative correlation, A is expected than B and B expected to be larger and B is expected to be lesser value. If it is independence means covariance of A comma B is equal to 0. But the converse is not true in this case. So some cases, two random variables will have a covariance of 0 but not are independent, they are dependent to each other. So this is about data integration. So whenever you are performing data integration, you have to handle the redundancy problem and also you have to handle the entity identification problem. So to identify the redundancy between the two data values, you can perform correlation analysis and covariance analysis. Next, we'll move to data reduction. So data reduction is about you will be reducing the dimensions of the data so that the data can be processed easily or effectively. So you will be obtaining a reduced representation of the data that is smaller in volume but produces the same results. So once you performing data reduction, the result of the data obtained by the process will be of same, but the size of the data will be of less. So why we need to perform data reduction? So what is the main reason for performing data reduction is to avoid the storage issues. So yeah, big database or a data warehouse has to store large amounts of data. At that case, the size of the database is not available to store that amount of data. In that case, we will be performing data reduction strategies so that the dimensions or volume of data will be reduced, but the context of the data will be preserved. So you have different methods for data reduction, that is dimensionality reduction, numerosity reduction, and data compression. So under dimensionality reduction, you will be removing the unrequired values or unimportant attributes or tuples. So you have three different methods for dimensionality reduction, that is wavelet transform, PCA, that is principal component analysis, feature subset selection, and feature creation. Under numerosity reduction, under numerosity reduction, you have three different methods, that is regression, log linear models, histograms and clustering, sampling, and at last you have data cube aggregation. You have one method, another method, that is data compression, that is you will be compressing the data by applying a different compression algorithms. So this is about different data reduction strategies, that is dimensionality reduction, numerosity reduction, and data compression. So first we'll move to a first method, that is dimensionality reduction. So under dimensionality reduction, you have to handle one problem, that is curse of dimensionality, which means when the dimensional data increases, data becomes sparse. So you have to avoid the curse of dimensionality problem, and you have to make a dimensionality reduction. So the possible combination of subspaces will also grow exponentially in this case. So when the dimension increases, the amount of information we gather from the data reduces. So this dimensionality reduction will help us to eliminate the irrelevant features and noisy values, and also it will be reduce the time and space used in data mining and machine learning process. And also this dimensionality reduction will allow for easier visualization of data. Next, we have dimensionality reduction techniques, that is wavelet transform, PCA, supervised and nonlinear techniques. So what does wavelet transform is? You will be decomposing a signal into different frequency bands. So this wavelet transform will be mostly applied to the power signals or voltage signals. So it is especially useful for electrical engineering applications. That is wavelet transform for data reduction. So data will be transformed to preserve the relative distance between the objects at different levels of resolution. That is different resolution levels can be preserved. So this will be mainly used for image compression. Next one is principal component analysis. So principal component analysis in the sense you will be given a data set. From the given data set, the principal components or in the principal attributes will be captured or collected. So or it will be reduced to the principal important components. So this is about principal component analysis. We'll be identifying the important or most crucial value, attribute, or tuples for a given data set. So here you will be using a eigenvectors, covariance matrix, all those things. Next one is attribute subselection method. So another way to reduce the dimension of data. So here what you will be doing is you will be selecting the redundant attributes and irrelevant attributes and you will be deleting them. So redundant attributes in the sense duplicate much or all of the information contain one or more attributes. Irrelevant in the sense contain no information that is useful for the data mining task at hand. So you will be omitting or deleting the repeated attributes. For example, purchase price of a product and the amount of sales tax paid. Irrelevant in the sense student ID is often irrelevant to the task of predicting the student's CGPA. So under data reduction, you will be performing attribute subset selection. In that case, you will be selecting only the important attributes for performing the reduction process. Next one is feature generation. So what you will be doing is you will be creating a new attributes or a new feature that can capture the important information dataset more effectively than the original ones. For example, if we need to calculate the retirement age of a particular person, and if you are supposed to have an date of birth, in that case you will be eliminating that particular attribute and you can calculate the new attribute that is called as age. So that is about feature generation. So you will be given one feature. With that feature you can calculate the another feature that is most important for a machine learning task. For example, if you are given a length and a breadth, in that case you can calculate the area of a particular object. So here you have three methods, that is our attribute extraction, mapping data to a new space, and attribute construction. So using these three methods you can perform a attribute creation process. Next one is numerosity reduction. So here what you will be doing is you will be reducing the volume or size of data by choosing alternative smaller forms of data representation. Here you have two different methods, that is parametric methods and non-parametric methods. So parametric methods in the sense you will be using regression. So here the data will be with some model, estimate the model parameters, stores only the parameters and discard the data. So here you will be using linear log models. Whereas non-parametric methods, you will not assume any models. Here you will be using histograms, clustering, and sampling. So linear regression in the sense you will be data will be modified to a fit a straight line. Multiple regression in the sense will be allow a response variable y to be modeled as a linear function of multi-feature vectorial. Here you will be mapping between two variables in linear regression. Multiple regression you will be mapping between multiple variables. So log linear models you will be approximating the multidimensionality probability distributions. Next one is regression analysis. So what is regression analysis is will be finding the relationship between the dependent variable and one of the independent variable. So here once you find the relationship between the variables, you will be drawing a line of best fit. So here I have x-axis and y-axis. That particular line will be called as a line of best fit, that is y is equal to x plus 1. So it matches most of the data points. So here you will be using a least square method to perform the analysis. So next you have different regression types, that is linear, multiple, and log models. Here I have given or I have specified the expression for each of these models. You can make a note of it. That is linear regression is y is equal to x plus b. Here a denotes the common variable. That is x denotes an dependent x denotes an independent variable, whereas y denotes a dependent variable because the value of y is always dependent on the value of x. So it will be called as a dependent variables. Multiple regression in the sense b0 plus b1 x1 plus b2 x2. So here non-linear functions will be transformed to the above. Log linear models in the sense you applying discrete multidimensionality probability distributions. So here what you will be doing is you will be estimating the probability of So here what you will be doing is probability of each point in a multidimensional space for a set of discretized attributes based on smaller subset of dimensional combinations. So this log linear model is mostly useful for dimensionality reduction data smoothing process. So this is about histogram analysis. So here what you will be doing is here you will be dividing the data into multiple buckets and you will be storing the average of values in a particular bucket. So you will be categorizing the data into multiple buckets and you will be finding the average and you will be representing by means of histogram. That is of bar chart. So here you can categorize into equal width, that is equal bucket range and equal frequency bucket range. Next one is clustering. So clustering in the sense you will be partitioning the similar data into one clusters or one group. So that will be called as a clustering analysis based on similarity or store the representation. If the data is clustered, if it is of very effective if we cluster the similar data, or non-effective if we not cluster the similar data. So under clustering, you have multiple algorithms, that is linear, hierarchical, density-based clustering. Next one is sampling. So what you will be doing is instead of representing the whole data, you can select a sample of data to represent the whole data. That is about sampling. We'll be collecting a small sample yes to represent the whole data set here. So here you will be choosing a representative subset of the data by means of simple random sampling and adaptive sampling methods. So sometimes the simple random sampling will have a poor performance in the presence of errors or skewness. You have different categories of sampling. As you can see the screen, simple random sampling, sampling without replacement, sampling with the replacement, stratified sampling. So simple random sampling in the sense equal probability of selecting any particular item. Sampling without replacement is once you select an object for a sample, it is removed from the population. Sampling with the replacement is an object is not removed from the population. Stratified sampling in the sense you will be partitioning the data into different data sets and you will be draw samples from each of the partitions. Next, you will move to the compression. That is the last part of data reduction. So you have different categories of compression. That is string compression, audio or video compression. So string compression in the sense you will be compressing the values in order to avoid cyberbullying or in order to avoid privacy or in order to have a privacy preserving of data. Audio or video compression is mostly done to reduce the size of a data. So original data, you will be applying some compression, either lossless or lossy compression. Lossy compression in the sense some of the data will be lost, whereas lossless compression in the sense without losing the originality of the data, you will be performing compression process. So this is about data reduction. So next we'll move to data transformation and data discretization. So data transformation in the sense you will be using one function that maps an entire set of values of a given attribute to a new replacement values. That is, you will be transforming a data or a given tuple into a new form. So here you have different methods. That is smoothing, attribute construction, aggregation, normalization, and discretization. So we'll move to normalization. Normalization in the sense you will be replacing the values with the normalized value, that is either a minimum value, maximum value, or an average value. So for normalization, you have different types, that is min max normalization, z-score normalization, and normalization by decimal scaling. So instead of representing the same value as that of same, you can perform the normalization process. Discretization. So here you can consider three type of attributes: nominal, ordinal, numeric. Nominal values is nothing but color or profession nominal. Ordinal is nothing but academic rank. Numerical is nothing but a real value. So what you will be doing under discretization is you will be dividing a range of contribute values into an intervals. So you will be given a values. So you will be dividing into multiple intervals. So and also you can represent each of the group or set in by means of interval labels, all those things. So you have different data discretization methods: binning, histogram analysis, cluster analysis, decision tree analysis, and correlation analysis. So all those things we have seen previously. So binning will be applicable mostly to unsupervised data, that is, the data doesn't carry any data labels. Whereas histogram analysis also supported for unsupervised data, clustering also unsupervised data. Whereas decision tree analysis, the data must have a data label to perform a decision tree analysis. So binning in the sense you will be dividing, you will be sorting the data and you will be dividing into multiple groups, and you will be replacing the each of the groups by means of a average value or equal with value. So that is about distance partitioning and frequency partitioning. So you will be dividing the values into n intervals of equal size uniform grid. Here you will be dividing the range into n intervals, each containing approximately same number of samples. So this is about binning methods of equal frequency, bin means, and bin boundaries. So under bin means, you will be replacing the values by mean of each bins. So here you will be categorizing the given data into 4 bins: 4, 8, 9, 15, 1 bin, 21, 21, 24, 25, 1 bin, 26, 28, 29, 34 into another bin. So in the bin means method, you will be replacing each of the value by mean of the values in a particular bin. Boundary in the sense you will be replacing the values by means of boundary of the values. If supposed to be 4, 8, 9, 15, the boundary will be 4 and 15. So 4, 4, 4, 15. This is about different categories of binning methods. Bin means, bin boundaries, and equal depth bins. So classification will be categorized into supervised, top down, whereas correlation analysis in the sense supervised and bottom up. So concept hierarchy generation in the sense it will be representing the values by means of an hierarchy. For example, a person, men and women, men, boys, adult in that fashion will be hierarchy will facilitate drilling or rolling to granularity. So this is about concept hierarchy. For example, country, state, city, street. This is about concept hierarchy. So you will be representing the values by means of hierarchy so that it will be very useful for processing. So this is about hierarchy, that is country, state, city, and street. So with that, data pre-processing is over. So under data pre-processing, we have seen what is data quality, what is data cleaning, what is data integration, and what is data reduction, data transformation, data discretization. Next, we'll move to feature engineering. So feature engineering is something about you will be translating the data set into features such that these features are able to represent the data set more effectively and resulting in more performance. So if you are supposed to given one data set that has multiple rows and columns, from the data set you can represent some of the rows or some of the tuples alone so that it gives a better representation of the whole data set. That is, you will be performing addition, deletion, combination, mutation for your data set to improve the model training, leading to high performance and high accuracy. So it is one of the preparatory activities of data pre-processing, and you will be taking a raw input data and you will be converting that into well aligned features which may be really useful for machine learning models. So this feature engineering will be encapsulating various engineering tasks like selecting the relevant features, handling missing values, encoding, and normalizing. So feature engineering has two elements: feature transformation and feature subset selection. So feature is nothing but a particular attribute that is used for a machine learning process. Feature subset selection means you will be selecting a combination of features, that is redundant combination of features that will be useful for improving the performance of a machine learning model. Whereas feature transformation in the sense will be applying some mathematical formula to a particular column or a feature, and you will be transforming that particular column to a different values. So which is nothing but you will be creating a new features from an existing features that will be help in improving the model performance. This feature transformation also again has two major elements, that is feature construction and feature extraction. So both will be sometimes called as a feature discovery. So what is the main goal of this feature transformation processes? To achieve the best reconstruction of the original features in the data set, and also to increase the accuracy in the machine learning models. So this is about feature engineering.